Okay, before we start looking at question 3, we are going to revise a little bit key ideas for vectors. So vectors are mathematical objects that has size or magnitude and a direction. For example, movement from a point A to point B can be described not only in terms of how far B is from A, but also in what direction B is from A. Okay, a scalar would be a quantity that has size only. Examples of scalars would be things that you know really well from real life, like masses, length, time. So basically vectors is kind of creation of our mind that actually was found very useful, especially in physics. The magnitude of the vector is given by the length of the line, and we'll come to this a little bit later, how to find the magnitude of a vector. And the direction will be given by an arrow. Okay, what else I would like you to remember is just, for example, if we want to describe a movement from a point A to a point B. In our example, this movement can be described on a grid with two different movements. One is one movement across, 6 units across to the right, and 3 units up. We can represent this movement using a column vector, where the first number always responsible for the movement across. So if you're moving right, it will be positive number. If you're moving to the left, it will be negative number. And the second number always will be responsible for the movement up or down. So if you're moving up, in our case 3 units up, it's going to be a positive number, and if you're moving down, it will be a negative number. That's it. So let's now talk about our question 3. In question 3, we are asked to name a vector which is equal to certain vectors, alright? And I would like you to have a go, but before you go, just remember what two vectors are considered equal. And since every vector is described with its magnitude and a direction, then we can say the two vectors, say n and b, will be considered as equal if they have the same length and also the same direction. So for example, if two vectors like this would have the same length but different direction, we would say they are different things. If two vectors would have the same direction but different length, we can't say that they are the same. They would be different for us. So for two vectors being equal, we must consider two things, direction and length. So have a go on this question, pause the video and check your answers afterwards. Okay, I hope you would come to the same answers as myself. So question A, we need to find a vector which would be equal to vector P. So let's find our vector P. Vector P is here. We could say vector P is 2 units across. Right, so vector P is 2 units to the left and 1 unit up, and we need to find vectors that would be describing the same movement. So here it is, the vector W. So the vector W would be the same as my vector P, because this vector has the same length and the same direction. Okay, now the next one is going to be vector 2M. We need to find the vector M. Here it is. We're moving 2 units to the right and 2 units up. But I need to have two vectors like this. So I expect I will be looking for a vector which would be 4 units across to the right and 4 units up. And let's see. Here is this vector. Vector C seems like the vector that I'm looking for. 1, 2, 3, 4 across and 4 units up. So exactly the vector C has to be the same as 2m. The next question, C. 3w. Okay, 3w. Where's our w? W is here. So 2 units to the left, 1 unit up. To have 3 vectors like this, we're moving not 2 but 6 units to the left and 3 units up, and this vector is going to be in the same direction as w. So here's this vector that might fit our expectation. So we expect 6 units across indeed and 3 units up. Exactly the vector z will be good for us. Okay, and now the question D. Minus k, minus k. The vector minus k is going to be the same as the vector k, only other way around. So having opposite direction, but the length has to be the same. So everything what we need now to find, we need to find a vector, the vector which would have the same length, only opposite direction. Here it is. It is the vector m. The vector m. Okay, A, B, C, D. Now the question E. Minus 2h, minus 2h. Alright, we need to find a vector which will be twice as long as the vector h, right? Because it's 2 times h. But also it has to go into opposite direction because we are looking for a vector which has opposite direction to h, minus h. Okay, so first of all, where is our vector h? Here it is, the vector h. And we have to move now not 1 unit to the left, but 2 units to the left. And not 3 units down, but 6 units down. So 2 and 6. 2 and 6. And also this vector has to go other way around. So 2 units to the left, 6 units down, and also our vector has to go up. So we have found the vector S. A, B, C, D, E, F now. Question F. Minus quarter of B. So alright, let's find the vector B. The vector B. This minus sign tells us that we are going to look for a vector which will be going into opposite direction. So we are going to look for a vector which goes down, and it has to be 1/4. The length of that vector has to be 1/4 of the length of our original vector. So it has to be 1 square down. Here it is, exactly the vector n satisfies our expectation. So 1/4 minus 1/4 of b will be equal to the vector n. A, B, C, D, E, F. So now G. Minus half of m. Minus half of m. Here's vector m. We need half of vector m, so it will be half. So just one diagonal of 1 square, and it's going to be minus half of m. So I'm going to look for a vector which goes this direction, but and it's just one diagonal. Exactly the vector q. The vector q. A, B, C, D, E, F, G, H now. H, minus 1/3 of f. Minus 1/3 of f. So where is our vector f? We are looking for 1/3 of vector f, and it doesn't go this direction. It has to go other way around. Again, our vector q should work. Okay, now the question I, 2q. We have our vector q, and we need to have 2q. So therefore we are not moving only 1 unit across, 1 unit down. We're moving 2 units across, 2 units down. So on which vector would satisfy this? The vector k. So we can say I is 2q is the vector k. Okay, J. is 1/3 of z. 1/3 of z. Where is the vector z? Here it is, and we need to have 1/3. So the vector z is actually moving 1, 2, 3, 4, 5, 6 units across. So 1/3 of this is going to be 2 units. 6 divided by 3, so it's going to be 2 units across, and it's not 3 units up, but just 1 unit up, because 3 divided by 3 is 1. So we're looking for a vector, which will be 2 units to the left, 1 unit up. 2 units to the left, 1 unit up. Seems the vector W will be good for us. And the final question K. The final question K, let's write it here. 2/3 of F is going to be, the vector F is 3 units across, 3 units up. So the direction will be the same as the vector F, up across, right? And 2/3 of 3 and 3 is 1/3 of 3 will be 1, and 2/3 will be 2 units. So it is 2 units across, 2 units up, 2 units across, 2 units up, 2 units across here. So the vector N seems should be good. Here's the end of the video and the end of the question. I hope it was clear. Thank you.